good to be here with you. This is my first conference to get to attend. It's been a pleasure. Attended a lot of the classes and I learned a lot. It's really good stuff. I appreciate the invite to be here. First of all, let me tell you a little bit about my city, city of Hot Springs. This thing's going. There we go. City of Hot Springs is located in the Ouachita Mountains. It's west central Arkansas. The Native Americans used to call this place the Valley of the Vapors for the obvious reasons, for the hot springs. Little known fact, in 1832, President Andrew Jackson declared Hot Springs as its first federal reservation, later turned into the first national park, predating Yellowstone by about 40 years. We have about 6 million visitors each year that come through Hot Springs just to visit. They visit our Bathhouse Row. That's one of our famous areas downtown, the thermal basin. Still active today. You can still enjoy the hot springs and take advantage of that. We're also home to one of the world's class botanical Garvin Wooden Gardens there in Hot Springs. We also are really getting big into the mountain biking. We have about 44 miles of mountain biking trails thanks to the Walton Foundation. And that's on property that the utility that I'm responsible for, about 2,000 acres. So that's become really popular. A little bit about my utility that I work for. We serve a population of about 90,000 people. We have about 1,000 miles of pipeline, and we're averaging about 18 million gallons of water a day out of our water treatment plant. And we have 2 facilities that we treat water out of currently, and getting ready to build a third one. I'm here today to talk to you about the utility and our journey on this digital transformation. I'll be the first to admit utilities haven't done a very good job of transforming into the digital world. I'll date myself a little bit. Back in the 1980s, we all have SCADA systems, but we just hadn't done a very good job of protecting those SCADA systems. So I'll date myself a little bit. I had one of the first Genesis systems that went into our plant, and we thought that was the greatest thing since sliced bread, I guess, the commercial, Super Bowl commercial. But we found out later it wasn't. We thought at the time we were really advanced, but we've come a long way since then. But I'm here to talk about our water treatment plant and our filter improvement project and how we transform into this digital journey that we're about to partake. As our system demands grows and regulations change, upgrades are necessary, of course. While upgrading our 9 filters at our water treatment plant, we decided to enhance our SCADA at that time technology. We were first introduced to SCADA with our wastewater lift stations. Our wastewater department's very big in Hot Springs. It's very hilly country, so we have to pump water a lot uphill. We have 88 major lift stations in Hot Springs, and we have over 3,400 grinder stations, and that's a lot of stations. And before we had SCADA systems, we had to visit each one, and I only have a crew of about 14 people to do that, so that's just impossible. So SCADA systems came along, and that really helped us keep our employee numbers down and costs down. Seeing the value and the ability to monitor and respond to real-time situations, we incorporated this into our water production facilities and our distribution system. Our recent upgrades at our Ouachita water treatment plant filter operations afforded the opportunity to incorporate more enhanced technologies, including cybersecurity. These are the companies that we chose to help us with this journey. Christ Engineers is our water engineers. I've worked with them for over 30 years now. got a lot of trust in them to steer us in the right directions. As I've worked with Brown Engineering since I've been in Hot Springs, they're the ones that have formatted our SCADA system, and we're an ignition-based system, and Dee takes care of all that for us. Dee Brown, he's here with me today and be on the panel. Dee brought us Bedrock, and that's where we're going to introduce Bedrock into our filtering plan at this time and for our cybersecurity protection. Our project goals was to enhance filter operations while eliminating outside security threats. And we used controls that would work with, one of the most important things is it had to work with our ignition system. Here you'll see some of the transitions that were made. These are some of the old filter panels that you'll see on the left side of the screen there. And on the right there, you'll see one of the new filter panels. One of the old filter panels, it took over 30 manual steps to backwash a filter. And operators had to remember that process. And then we always constantly having to train new people, and it was just a real problem. So you'll see on the right, we have one of the new panels, and to start a backwash cycle with one of the new panels, it's pretty much just as simple as pushing a start button, and it gets it started. We wanted our operators to stay engaged with that process and stay visually watching the filters as they backwash. So we put in a few pauses along the way to make sure they stayed engaged, and I didn't want them backwashing their filters from the couch watching the Super Bowl game or something. So we wanted to make sure that we kept them there at the facility and watching. So we could have, obviously we could have replaced, we had 9 filters. We could have done all 9 filters with one panel, but I wanted the operators to watch what was going on while the backwash cycle was happening. So we went ahead and did 3 different panels. Because there's just not one location in the plant that you could see all 9 filters with. This slide shows you the before Bedrock controllers. Flow rates were very erratical. You can see on the left, as the graph shows you, the filters were constantly searching and hunting for their happy spot. This was 24 hours a day, 7 days a week. This never stopped. After we installed the Bedrock controllers, the picture on the right shows all 9 filters working together as one. And it was a great thing when this day happened to us. We were very happy. It's a whole lot less wear and tear on equipment. And as you can see, it's working a whole lot more efficient. We needed to make this easy for our operators to control the backwash part of the process because, that's the most important part of a filter is backwashing it. A lot of things can go wrong during that process, and we wanted to keep them engaged, and that's just the most important part of backwashing your filters. The rest of it is pretty much like watching grass grow. There's not much to do. So we needed to be able to backwash based on turbidity readings and not a time-based backwash. That was one of our goals, and that's the whole point of this presentation here today. Why is that important? Of course, we don't want to waste water, and that was the whole reason we switched from a time-based backwash to a turbidity-based backwash. So here's a little bit how we did that. My team worked with Dee Brown's team. We developed this operating system for our filters. We wanted it to do everything. I needed to take the guesswork out of everything for my operators, but before this project, I mentioned that we backwashed based on time. What that looks like is basically an operator goes through about 20 steps, gets the filter backwashing, and then he sets a timer, and for 15 minutes he backwashes a filter. That's just wear and tear on your media. The filter may be clean in 5 minutes, but they're taught to do that for 15 minutes, no matter what. That process uses about 75,000 gallons of water per backwash, and that's 9 filters uh, per day. Uh, that comes out to a lot of water. So once we switched to the new process and started backwashing our filters based on turbidity readings, that dropped to around 30 to 50,000 gallons per backwash. So that saved us about 225,000 gallons of water a day. And that's over 82 million gallons of water a year. And dollar wise, that's about $50,000 worth of chemicals that we save each year now by switching, making this transition. So what's up next for us is this is our switch gear. It's being installed now. It's scheduled to go online the first week of March. This switch gear is no little project. It weighs about 90,000 pounds, and it's being controlled and operated, of course, and protected by bedrock controllers. Up next for us after that, we're in the process of designing a new 15 million gallon a day water treatment plant and a raw water intake on Lake Ouachita. This is a very exciting project for us. We're going to be micro tunneling through a mountain, 2,200 feet with a 60-inch tunnel. It's no small task, but we're going to be making a lake tap. And on the other end of that pipe, of course, there'll be a valve that's controlled there. And we're going to gravity feed water from Lake Ouachita 17 miles across the city to the other side of our city to a treatment plant where we'll be building it. And so that'll be gravity fed. So that's a perfect situation for us. We never have to pump water again. And on the way, we'll be dropping water off to the existing filter plant too. So that's a very exciting project for us. With that's all I've got. If you have any questions, I guess we'll handle that in just a little bit.